Hello everyone, this is Abhishek Mohanty and welcome to lecture number 2 of the chapter Electric Charge and Field. In the previous class, we had discussed about what is the meaning of charge, the types of charges and the basic properties of charges like the additive nature of charge, the quantization of charge and the conservation of charge. Today, we will discuss about 3 different methods of electrifying or charging a body. So students, in the previous class we had discussed that in a neutral body we have equal number of positive and negative charges. We know that in an atom protons are the positively charged particles and electrons are the negatively charged particles. Protons and electrons, they carry equal amount of charge, but their polarities are different. Protons are positively charged and electrons are negatively charged. So if in a body protons and electrons, they are in equal numbers, then the body or the atom will be neutral. So in order to electrify a body or in order to charge a body, we have to imbalance the number of protons and electrons, or we have to imbalance the number of positive and negative charges. So there are 3 different methods by which we can imbalance the number of positive and negative charges. So today in this class we'll discuss about all those 3 methods. So the 3 methods are, the first one is by friction, the second one is by electrostatic induction, and the third one is by the method of or by conduction. So these are the 3 methods to electrify or to charge a body. So we'll discuss the first one, the method of friction. So you have already studied about this method in the lower classes. So students, remember that when 2 suitable substances are rubbed against each other, then one body will lose electron and the other body will gain electron. So the body which will lose electron, it will acquire a positive charge, and the body which gains electron will acquire a negative charge. So here we have to rub the 2 bodies against each other, and due to the friction between the 2 bodies or the 2 substances, there is transfer of electrons from one body to the other body. So let me write this point. When 2 suitable substances are rubbed against each other, one body loses electron and the other gains electrons. The body which loses electron, acquires a positive charge, and the body which gains electron, acquires a negative charge. So this is known as the method of friction to electrify or to charge a body. So if I want to give example, I can say that when you rub glass rod with silk cloth, when we rub a glass rod with silk cloth, what happens? Electrons are transferred from glass rod to silk cloth. That's why in glass rod the number of positive charges become more than the number of negative charges, because the glass rod loses electrons, means the negative charges that are transferred from glass rod to silk cloth. So here in glass rod, the number of positive charges becomes more than number of negative charges. That's why the glass rod acquires a net positive charge. And since the silk cloth gains electrons, the number of negative charge increases, means the number of negative charges becomes more than number of positive charges, and that's why the silk cloth acquires a negative charge. So in this method, by the method of friction, you can transfer electrons from one body to the other body, and due to that the bodies becomes charged. Now one question arises, when we are rubbing two bodies against each other, suppose we are rubbing substance A with substance B, then which body will lose electron and which body will gain electron? Which parameter decides that this body will lose electron and that body will gain electron? That parameter is known as work function. Work function. So what is the meaning of work function? Work function means it is the minimum amount of energy required to remove electron from a body. Work function means the minimum amount of energy required to remove electron from a body. And for different substances, we have different values of work function. Suppose I will rub a substance A with substance B, and suppose phi A is the work function of A and phi B is the work function of B, and suppose phi A is greater than phi B, means substance A has more work function than substance B. It means we need more amount of energy to remove electron from A than B. So it is easier to remove electrons from B because we need less amount of energy to remove electrons from B. So when you are rubbing A with B, the substance B will lose electron and substance A will gain electron, means the substance having higher value of work function will gain electron and the substance having low value of work function will lose electron. So B will become positively charged and A will become negatively charged. So remember that this parameter work function decides which substance will lose electron and which substance will gain electrons. And remember that in this method, when you are rubbing A with B, the number of electrons lost by one body is exactly equal to the number of electrons gained by the other body. In this example, when you rub glass rod with silk cloth, suppose imagine that the glass rod will lose 10 number of electrons. Then the silk cloth will gain exactly 10 number of electrons. Means the number of electrons lost by one body is equal to the number of electrons gained by the other body. Means there is no loss of electrons, or you can say that the conservation of charge holds good in this method. So this is all about the method of friction to electrify or to charge a body. Now we will discuss about the second method, which is by electrostatic induction. So what is the meaning of the method of induction? Induction means without any physical contact. The first method रे हमें देखिले जे when we rub the two bodies against each other, there is a physical contact between the two bodies. But in the second method, in the method of induction, there will be no physical contact between the two bodies. So let us discuss about this method. If a charged body is brought near an uncharged body, the charged body will attract opposite charge and repel similar charge present in the uncharged body. The side of the uncharged body which is closer to the charged body becomes oppositely charged, while the far end becomes similarly charged. If any one side of the body is grounded, it becomes a charged body. So ये तीनटा पॉइंट पढ़ला पर हमें डिस्कस करिबा गोटे एग्जांपल नबा how this method works. Suppose I will take a spherical metallic body, and the metallic sphere will be placed on an insulating stand. This is a metallic sphere, and this metallic sphere is neutral, means it has equal number of positive and negative charges. And this metallic sphere is placed on an insulating stand. Let us say the stand is made from glass or plastic or wood. Now you have to take another charged body. This body may be positively charged or may be negatively charged, and in this example I have considered that the second body is positively charged. So kon lekha hoichi, if a charged body, means this one, is brought near an uncharged body, this is the uncharged body, then the charged body will attract opposite charge and repel similar charge present in the uncharged body. So we have taken a metallic sphere. Inside the metallic sphere we have electrons and protons, and we know that the protons are inside the nucleus, which cannot move, but the free electrons can move. So since this body is positively charged, this body will attract the electrons present in the metallic sphere, because we know that unlike charges attract each other and like charges repel each other, means positive charge will attract negative charge. So due to this electrostatic attractive force, what will happen? The electrons in the metallic sphere will be accumulated in this end, at this end, the end which is close to this charged body. Is that clear? Means we'll have more concentration or more density of electrons at this end. So this end will become negatively charged, and at the farther end, at the right end, what will happen? We will have less concentration or deficiency of electrons, means this end will become positively charged. Is that clear? So when you bring a charged body near an uncharged body, this charged body will attract opposite charge. Since this is positively charged, it will attract the negative charges in the sphere, and it will repel the similar charge in the uncharged body. Means due to the repulsive force, at the farther end we will get the similar type of charge. But if you take the charged body to be negatively charged, then what will happen? This negative charge will repel electrons to the right side, means at the right side we will have negative charge, on the left side we will have positive charge. Is that clear? The side of the uncharged body which is closer to the charged body. Now this side of the uncharged body is closer to the charged body, so that side becomes oppositely charged. Means जदि हमें charged body को positive नहीं थिबा, then the closer end of the uncharged body becomes negative charge, and the farther end will become positively charged. So the side of the uncharged body which is closer to the charged body becomes oppositely charged, while the far end, this is the far end, it becomes similarly charged. Now if any one side of the body is grounded, then the body becomes charged body. So let us see how we can ground a substance or a body. So now you can see that the charges are induced in the body, and there is no physical contact between the two bodies. There is no physical contact between them. तबे मैं कौन करेबी? Now I am drawing the second diagram here. Now the charges have been induced. At this end we have negative charges, at this end we have positive charges, and here I have this positively charged rod. Is that clear? And this is an insulating stand. So now if I connect this right end to ground, this is known as earthing. So in this case what will happen? Remember that earth is at zero potential. Earth is always at zero potential. In class 10 you have studied about what is the meaning of electric potential. So remember that earth is always at zero potential, and we know that potential difference is the main reason behind the flow of charge. Without any potential difference, charges can never flow. So earth is at zero potential and the right end is at positive potential. Positive potential means higher potential, means this positive is higher than zero. So when you connect two ends or two bodies which have different potentials, then definitely there will be flow of charges. And remember that electrons or any negative charge always flows from lower to higher potential. Any negative charge flows from lower to higher potential. So if I connect the right end to the ground using a metallic wire, what will happen? The ground is at zero potential and this end is at positive potential, means positive is higher than zero. So we can say that the ground is at lower potential and this end is higher potential. So the electrons will flow from the ground to this end. Is that clear? Electrons will flow from ground to this end of the body, and the flow of electron will continue up to the until all the positive charges are neutralized. So this is the ground is at lower potential, this end is at higher potential, so electrons always flow from lower to higher potential. So now you'll see that the electrons will flow to this end and they will neutralize the positive charges. Now what will happen? We have this metallic sphere, all the positive charges now are vanished. All the positive charges are vanished. We are only left with the negative charges. So you can say that by grounding this end, we have removed all the positive charges induced at the farther end. But now due to attractive force, the electrons are accumulated at this region. Now if I take this positively charged body away, then what will happen? All the negative charges will distribute all over the body. Is that clear? So you can see that by the method of induction we have electrified or we have charged a body and there is no physical contact between the two bodies. So this is known as the method of induction. So here I have taken the example of a metallic sphere, but remember that you can induce charge in non-metals also. So charges can be induced in metals and non-metals, and there is a formula by using which you can calculate the amount of induced charge. So remember that the charged body, this is the charged body which is used to induce charge in an uncharged body. So the charge which is used to induce charge in an uncharged body is known as inducing charge. Let us say Q is the inducing charge. Q is the inducing charge, and the charge which is induced in the body is known as induced charge. So Q dash is induced charge. Q dash is induced charge. Remember that if the inducing charge is positive, then induced charge will be negative, and if the inducing charge is negative, then induced charge will be positive. And there is a relation between Q dash and Q. What is the relation? Q dash is equal to minus Q whole into 1 minus 1 by K. Q dash equal to minus Q whole into 1 minus 1 by K, where Q dash is the induced charge, Q is the inducing charge, and what is K? K is the dielectric constant. Dielectric constant of the medium. Dielectric constant of the substance, not medium, substance. And what is dielectric constant? We'll discuss about it in the next class. So this formula is used to calculate the value of induced charge. Is that clear? So we have finished the first two methods of charging or electrifying a body. Now we have the third one, which is the method of conduction. So let's discuss about the third method by the method of conduction. So now we will discuss about the third method to electrify or to charge a body, known as the method of conduction. So in this method you have to take two bodies, one is charged body and the other one is uncharged body, and the two bodies must be conductors, means they should be metals. Suppose I have taken the two metallic spheres. The first one is positively charged, but the second metallic sphere is neutral. The second metallic sphere is neutral. Okay, and now we have to electrify or to charge the second body by the method of conduction. You can electrify this body by the method of induction, but we have to in this method we have to charge the body by the method of conduction. So let us discuss about this method. So in this method you have to bring the two bodies in contact with each other. So when you bring the two bodies in contact with each other, then what will happen? Let us discuss about that. This is the first body, this is the second body. Initially the first body was positively charged and the second body was neutral. So remember that when we charge a body, what happens? All these charges, all these positive charges, they will repel each other, and that's why they will try to stay at maximum distance from each other. That's why you have seen, you see that all the charges will lie on the surface of the sphere, because at the surface they will get maximum area, so that they can stay at maximum distance from each other. Because all the positive charges or all the negative charges, if you give it negative charge, then also there will be repulsive force among the negative charges. So the like charges, they always try to stay at maximum distance from each other. So they are lying on the surface, because on the surface they will get maximum area, and that's why they can have maximum distance from each other. But now when I bring the two bodies in contact with each other, then they will get more area. That's why the sum of the charges will be conducted to the second bodies. Now you can see that the charges will have more area, and that's why they can have more distance. They can stay at more distance from each other than in the first case. So in this method what happens? Some charges are conducted from the first body to the second body. Now you again separate the two bodies, you will get two positively charged bodies. So this is very easy method, and for the conduction of charge you need metals, because you know that in insulators charges cannot flow from one end to the other end. So you have to take two metallic bodies, so that the charges can be conducted from one body to the other body. So students, these are the three methods of electrifying or charging a body. Hopefully you have understood all the three methods. In the next class we will discuss about a very important formula, very important law, known as the Coulomb's law. So in that Coulomb's law we will discuss about the formula which will be used to calculate the force between two point charges. So till then, bye bye.